100 years ago, a man in his 20s rode a train back and forth between his office job. During these trips, he looked out the window dreaming about the universe. Albert Einstein discovered a truth about time and space itself. The truth is Einstein was a genius not for making complicated theories, but for making simple ones. This is not the story of the man, but the daydream that changed the world. This is a true story about time. You are about to see what he saw a century ago. But first, we need to learn 2 rules that guided his dreams. So buckle up, first stop's the beach. The first rule of Einstein's dreams is motion is relative. All this means is wherever you are, if you're not speeding up or slowing down, you can consider yourself stationary. For example, if you're lying in the hammock, you're not moving. You're strapped to a tree. The beach and palm trees are stationary, and the waves, wind, and the plane off in the distance are moving. This is one perspective. If you were sitting in the plane buckled up, when you look out the window, it's the islands and earth that is moving by below you. The hammock and plane view disagree on what is moving and what is stationary. Relative motion means there is no one right or wrong perspective. The trick is to only consider one view at a time. If you try and consider the view of the hammock and the plane at the same time, your head will explode. And viewing the world only makes sense from one place at a time. You may be tempted to think the view from the hammock is more stationary than the plane. But consider this. As you watch the sun from the hammock, you will see it sink down towards the ocean. But we all know the sun doesn't really go down. We're on the surface of a giant rock that's spinning at 1,000 miles per hour. The sunset is an example of relative motion. It's one of the few times of the day when you can feel completely stationary and at the same time stare at the earth rotating. That's relative motion. So sit back and relax. When it gets dark, we're going to space. This is the Milky Way, the galaxy we live in. Our galaxy has over 100 billion stars, and there are billions more galaxies out there. Relative motion makes more sense from out here. Everything is just floating in space. For the other rule you need to know before Einstein's discovery, we're going to go a little closer to home. Right now, we're on the outskirts of the galaxy, hurtling around the center at around 220 kilometers a second. Einstein was obsessed with light and imagining how it moved. The constancy of light is still a mystery. To see what this means, let's say you're on the moon and you're playing tag with an alien. If you're not running away fast enough, eventually you're going to get caught. Now you're it. If you're moving just a bit too slow, the alien will get away, but not by much. Now, let's say you play tag with a beam of light. When you shine a beam, it will move away from you at the speed of light. The weird part comes when you try and catch it. No matter how fast you chase, it will still move away from you at the same speed as if you didn't leave the moon. You see the light as if it speeds up when you speed up, so it keeps moving away at the same rate. Even if you move in the opposite direction at 99% the speed of light, you will still see it moving away at the same speed as if you hadn't run at all. You will always view light moving at the same rate. It can't be caught or run away from. Think of light as the only thing that moves at the same speed in all views. Now, if you're really confused, join the club. No one understands this. It was discovered accidentally in equations about electricity and magnetism in the late 1800s. It surprised everybody, and nobody really took it seriously, except for Einstein. By doing so, he discovered a connection between space, gravity, and time itself. To see what he saw, we're going to go to a magical place called Boston, Massachusetts. Einstein stumbled upon a connection between motion, gravity, and time. It all started with daydreaming during a commute. This is that daydream. Let's say you're on a platform as a train pulls up. And on this train is what Einstein called light clocks. A light clock is just two parallel mirrors with a particle of light bouncing back and forth between them. Each time the particle of light hits a mirror is one tick of the clock, and the yellow line is the path the particle takes. One clock is on the train, and another identical clock is floating above it. The floating clock will stay stationary with you in the platform and won't move even when the train pulls away. When the train is stopped, the clocks are synchronized and tick at the same time. When the train pulls away, if you trace the new path of the light particle in the moving clock with your finger, you will see it travel in a zigzag between mirrors. While the particle in the stationary clock takes the same path as before. Here's where the rules come together. Your perspective on the platform is just as valid as any other because of relative motion. And light always moves at the same speed. This is where the light bulb moment happens. The zigzag path is longer than the stationary path. So the particle on the moving train will take longer to go from one mirror to the other, and therefore take longer to tick. You will see the clock on the moving train ticking slower than the stationary clock. This is not a problem with the light clock. You will literally see time pass at a slower rate on the moving train. And therefore time does not pass at the same rate everywhere. Einstein discovered time is not rigid and constant. Time can slow down. The faster the train moves, the moving clock ticks slower because the path becomes longer and longer, and the light particle travels a longer distance between mirrors. The clocks only measure time at the same rate when they are stationary. In everyday life, clocks slow down so little because we move so slow compared to light speed. If you shine a flashlight at the moon, the particles leaving the light bulb will reach the moon in less than 2 seconds. The train would have to travel at a couple 100,000 miles per hour for light to take this much of a diagonal path. But time does change. Einstein's discovery did not stop there. An accelerating train also causes a light particle to travel a longer distance between mirrors. Each moment the path becomes more and more horizontal as the train speeds up, forming a curve. Years after his initial discovery about time, Einstein realized a connection to gravity. He realized gravity and acceleration are the same force. If you're in a train car in space, you will be weightless, floating with no gravity. But if rockets suddenly thrust the train car upwards, you'll be pushed into the floor. Just like when you hit the gas in a car, you get pushed into the seat. The force from the rockets push you into the ground. Right now, we're all being accelerated down by gravity. Einstein realized if the rockets accelerate the train in space at the same rate gravity pushes us into our seats, you could get up in the train car and walk around. If you couldn't see out the windows, you would have no idea you weren't on Earth. When Einstein realized this, he said he got so excited his heart fluttered. Because if acceleration is a form of motion, which causes time to slow down, and gravity is the same as acceleration, then gravity slows down time too. Gravity literally slows down the passage of time. A few miles above your head, time is passing at a faster rate than on the surface of the Earth, where gravity is stronger. This is not an unproven theory. When scientists launch a satellite into orbit, a clock on the satellite will tick normally when it's on the surface of the Earth. But when it gets launched into space, the clock speeds up and ticks faster with less gravity. On the moon's surface, there is less gravity than on Earth. So a clock on the surface of the moon will tick faster than an identical clock on the surface of the Earth. So the next time you see the moon, you will know time is passing faster up there. And the moon is aging faster than the Earth. If you were to remember only 2 things about Einstein's discovery, remember this. Time does not pass at the same rate everywhere, and gravity slows down the passage of time. A few miles straight up, time is going by at a faster rate. That is Einstein's daydream that he discovered by looking out the window. We have reached the end of this story. And if you have more questions than answers, join the club. At the edge of scientific knowledge, there are always more questions than answers. If a person were to know every fact humanity has uncovered about our world, the only thing they would be absolutely sure of is they know next to nothing compared to what's out there. And that can only mean one thing. The world is not what it seems.